Hi and welcome to Spinal Cord Part 2. In here we will begin by talking about the arterial supply of the spinal cord. First, the cervical spinal cord. Cervical spinal cord gets its arterial supply through branches of the vertebral artery. Here you have an image from the Atlas of Anatomia of the dog and cat from Roberti and Sotet. There is the vertebral artery. On MRIs, you see the vertebral artery as a branch of the subclavian artery. Here we are on the left side. So this is the left subclavian artery with the internal thoracic artery and the superficial cervical artery. This is the common carotid artery. The vertebral artery runs through the transverse foramina of the cervical vertebrae. The arterial supply to the first thoracic segments comes from the thoracic vertebral artery. This is a dissection on the left side. So you have some nerves that form the brachial plexus, the left subclavian artery here, and one of the branches is the costocervical trunk. There we have the costocervical trunk here. One of the branches of the costocervical trunk is the thoracic vertebral artery. That branches from this artery are spinal arteries that are going to supply arterial blood to the first thoracic segments up to T4. Other branches of this costocervical trunk is the deep cervical artery here. You have it in this MRI. For the rest of the thoracic segments, the arterial supply comes from dorsal intercostal arteries. These are the dorsal intercostal arteries. You have it in this dissection. Here you have the diaphragm, the esophagus, the aorta at the thoracic level, and branches on both sides. We have the dorsal intercostal arteries. Branches from these arteries are the spinal arteries that supply blood to the thoracic segments of the spinal cord. This is the sympathetic trunk, and we also identify the right subclavian, the right azygos vein. For the lumbar segments, the arterial supply comes from lumbar arteries that are branches from the aorta at the lumbar level. These are the celiac artery, the cranial mesenteric artery. Okay, these are the lumbar arteries on a transverse section coming from the aorta, right? And on MRIs, you see these small branches here, that are spinal arteries, branches from the lumbar arteries. Let's have a close look in dissections. So this is the vertebral column, right? This is L5, L4. This is a spinal nerve, right? And then we have, in a close look here, a lumbar artery, and a branch of a lumbar artery is the spinal artery. And look, it is located very close to the spinal nerves. As I have taken the nerve with the forceps, I have moved the spinal nerve out from the vertebral canal. So we identify the spinal ganglion, but this should be inside the vertebral canal. This is a view from the inside. This is the intervertebral foramen, and then you have the dorsal root, the ventral root of a spinal nerve, and then you have the spinal ganglion, very close to the intervertebral foramen. And in close contact with the spinal roots, we have arteries here. Close look, you have the ventral radicular artery and the dorsal radicular artery. These are branches from the spinal artery that in turn is a branch of a lumbar artery at this level. Let's have a look. We are at the level of the T1, the spinal nerve T1, okay? The rib has been removed. So we have the spinal artery and it enters the vertebral canal in close contact with the spinal nerve. Okay. Again, we look from the inside, the intervertebral foramen, and what we have done here is to remove the spinal nerve with the arteries. So we have the spinal nerve, in this case is L5, and you have the spinal ganglion very close to the intervertebral foramen, and the dorsal and the ventral root. Look, this is the lumbar artery, and a branch of it is the spinal artery that runs inside the vertebral canal and runs in close contact with the spinal nerve, right? Okay, so again, we see the lumbar artery, and a branch of it is the spinal artery. It's the one that is going to get inside the vertebral canal. And remember, the artery is in close contact with the spinal nerve. So the spinal nerve and the artery are very closely located and are located at the rostral position in the intervertebral foramen. Again, we see these signs of a vessel and running with the artery. So now we are at the lumbosacral level. This is L7, this is the sacrum, and this is the intervertebral foramen. If we look in closely, what do we see is the intervertebral disc, and there we have the spinal nerve L7 running with the spinal artery. And in this case, we have two intervertebral veins. These veins can be double, as it is in this case. So on we see in this MRI, as you see, the spinal nerve L7 here. This is a dissection. As you see, the sacrum, and this is L7, the spinal nerve L7, L6, L5. Okay. In this dissection, we look closely. Okay. This is the lumbar artery, and then you have the, this is the spinal artery that detaches the lumbar artery and is running with the spinal nerve L7. So these are MRI images, these are angiographies, and you see this is at the level of the lumbar vertebrae here, and you have these hyperintense signals here. They correspond to lumbar arteries. So we are running from ventral, number 1, and we run dorsally, 2, 3, 4, 5, and 6, right here. And then we see these are the lumbar arteries. At this level, it's easy to identify the deep circumflex iliac artery, okay? And then as we progress, we won't see the, in these angiographies, it is very, very difficult to identify the arteries that are running inside the vertebral canal. However, we can see these are the lumbar artery here, and this, as you see, this is what I want to point out, and that these arteries, when these lumbar arteries, they detach the spinal arteries, and these spinal arteries are very close to the spinal nerves. You see this dot here is the spinal artery that is beginning to detach from the lumbar artery and is running very close to the spinal nerve. As you see here, as you see in this sagittal section at the lumbosacral level, what you see, this is the spinal nerve together with the spinal artery. And caudal, again, we see two spinal veins. So when we see an MRI, it's a dorsal section, right? This is the spinal nerve with the spinal ganglion, spinal nerve, this is L7, L6. So the artery is in close contact with the spinal nerve. Well, what about these intraforaminal ligaments? The intervertebral foramen, it is not widely open, it's closed. It's closed by the outer layer of the dura mater and the deep sheath of the thoracolumbar fascia. Okay, there are some places well, all the structures that go through this foramen, they have to go through these layers, and in here you identify this foramen that corresponds to the intervertebral vein. The artery is located more rostrally. So at these foramina there are ligaments that they are intraforaminal ligaments and transforaminal ligaments here. These ligaments are very important and they are attached to the periosteum. They attach the periosteum to the spinal nerves and they are very important. This is an inside view of the vertebral canal after removing the duramata. You see a spinal nerve. This is an intervertebral foramen that hasn't been opened. So you see in a close look, you see the dorsal root, the ventral root, the spinal ganglion located in the dorsal root, very close to the spinal nerve. And you see there are attachments, ligaments. This is an intervertebral foramen and ligament. This is the ligament, interforaminal ligament. And ligaments that attach the spinal nerves to these intervertebral ligaments. And this is very important because when there is a stretching of a limb, the nerves, they also stretch. So they have to be attached to the intervertebral foramina in order to prevent lesions. So once this spinal artery has entered the vertebral canal, branches off in a ventral root artery and a dorsal root artery. These arteries run with the roots and they get to the spinal cord and they form a net around it. Okay, they form a net. Sometimes some arteries may be found as the dorsal spinal artery on the left, and there is one on the right as well, okay? And there is a big artery that forms on the ventral aspect of the spinal cord. This is the ventral spinal artery. On a transverse section on an MRI, you see the spinal cord, supraarachnoid space, right? Epidural space right here with the roots of the spinal nerves, the plexus venosus vertebralis internus ventralis, the dorsal longitudinal ligament, and here you have the ventral spinal artery inside the supraarachnoid space. This ventral spinal artery branches segmentally vertical arteries that are going to vascularize most of the gray matter of the spinal cord. The dorsal horns of the gray matter of the spinal cord and the white matter receive their arterial blood supply through radicular arteries. So this net is a very clever thing to do because when there is a lesion that affects one of the arteries, the blood supply may get through other locations. So this is a transverse section in the drawing, and this image is from this paper, okay? But it's very interesting because you see the spinal artery that branches in radicular arteries, the dorsal and the ventral, and they get to the spinal cord in order to form a net around it. Just one ventral spinal artery is very easy to identify. From it, the vertical arteries segmentally go out and enter the spinal cord and vascularize the gray matter, most of the gray matter. Remember that the white matter and the dorsal horns are vascularized by radial arteries. As you see here, this is the vertical artery entering the spinal cord and vascularizing most of the gray matter. These are the radicular arteries that vascularize the white matter and the dorsal horns of the gray matter. This is a corrosion cast where this in blue is the plexus venosus vertebralis internus ventralis, and this is the basilar, the ventral spinal artery. And as you see segmentally, the vertical arteries branch off from the ventral spinal artery. And remember, the ventral spinal artery located ventrally to the spinal cord in the subarachnoid space. Okay, this ventral spinal artery, when it gets to the encephalon, is going to continue as the basilar artery. However, there are particular things that has to be said. First is at the level of the first cervical spinal nerve, this ventral spinal artery, when it meets the basilar artery, opens in a rhombus-like structure, as you see here. So this allows us to identify these arteries, these two arteries, okay? So we know that we are at the level of C1, C2, cervical spinal segments. As you see in this corrosion cast, it opens. This is the ventral spinal artery, will continue as the basilar artery, and at this level, it opens in a rhombus-like structure. So, and then you can identify this is the opening, rhombus-like structure. This has been sectioned at the C1 level. And then this ventral spinal artery is quite big at this place. There is no, or if there are very thin, radicular arteries for the second cervical spinal nerve. And then there is a big one for, at the ventral aspect, for the third cervical spinal nerve. And as you see, there is a big one for the third cervical spinal nerve. So in these images, you see these are the roots of a spinal nerve, and you can identify the radicular arteries, the dorsal and the ventral radicular arteries. Okay, this is a dorsal view of a spinal cord, and then you can see that in the dorsolateral sulcus, this is the dorsal funiculus, you can identify the dorsolateral spinal artery, one on each side, and these dorsolateral spinal arteries are connected. On the ventral aspect, you see a mix of arteries and spinal veins. And again, this dissection of the spinal cord, the dura mater has been removed. So we see that these radicular arteries are running with the small roots that are going to form a spinal nerve. These are radicular arteries. An important feature is that this ventral spinal artery has a S shape, okay, at the level of the, or a sigmoid shape at the level of the intumescence. Here we are at the level of the cervical intumescence. And here we are at the level of the lumbar intumescence. You see, the ventral spinal artery has a sigmoid shape that can be identified on MRIs. Okay, there you have as well. You have this image has been obtained by injecting Indian ink into the vessels, right? So we have the ventral spinal artery here, okay, and radicular arteries. Here we are at the level of the lumbar intumescence. So on transverse section at the lumbar intumescence, you see the spinal cord. Look at the gray matter with the dorsal horn, the ventral horn, the central canal, and all the white matter around the subarachnoid space, right? So you see the ventral spinal artery right here, and you see that the ventral spinal artery is very close to the spinal cord. This is the ventral spinal vein. The ventral spinal artery is this one here, okay? It is not as close to the spinal cord as you see as the veins. The veins are more closely located. This is the ventral spinal artery with its thick wall, which is right here. So more images here. You see the ventral spinal artery right here, the ventral spinal artery. And again, in a close look, the ventral spinal artery, where we identify a vertical artery. And these are veins. It's a net of veins right here. It is important to notice that not all the radicular arteries are the same. In some routes, there is a lack of a radicular artery. In others, there is a big one, like this one here. This is the fifth ventral root artery, also known as radiculomedullaris magna, right here. Again, on a sagittal section on MRI, you can identify this sigmoid aspect of the ventral spinal artery, very close to the lumbar intumescence. So, talking about the root arteries, that not all the root arteries are the same, but there are some that are very big. At the cervical level, we have identified the first is very big, and the third is very big, the ventral ones. Usually the ventral ones are bigger than the dorsal ones. So we see if this is the ventral aspect, we are at the lumbar intumescence, and we see the ventral spinal artery here, and then becomes sigmoid here, right? Very close to the end of the spinal cord. And the big ones is on the left side, depends on the dogs, but usually the fourth ventral root artery, right? And the fifth ventral root artery. These are the biggest ones. And in human anatomy, they are called the Adamkiewicz artery. In particular, this one, the fifth ventral root artery. And again, you see these arteries marked here, right? The fifth and the fourth, right? And as you see in another images. There is the ventral aspect of the lumbar intumescence of a dog, and there it has been injected with Indian ink. And then what you see is the ventral spinal artery here. It has a sigmoid appearance, right? And there we have, at this level, we have the fifth ventral root artery, right here, on the right, right? And now I want you to show you something very interesting. Comparing the dog with the cat, what you see, what I have shown you before, is that the ventral spinal artery at the lumbar intumescence, here in particular at the cervical, it has a sigmoid shape here. However, in the cat, it does not. It is quite straight. You can identify the ventral radicular arteries here, right? Here we are at the level of C6, and here we are a bit more caudal at the level of C7 right here. And then you see how the ventral spinal artery in the cat, it has not this sigmoid shape appearance. It's quite straight. Okay. And in the cat as well, as you see, here we have moved to the lumbar intumescence, and we see the ventral spinal artery that is straight. And we also identify the fourth ventral root artery that should be the Adamkiewicz artery in the cat. There is not a fifth ventral root artery in the cat, just the fourth on the left. And then again, the ventral spinal artery, as you see, as we progress caudally, you see it is straight. It is not with a sigmoid shape as in the dog. So this is a study that I done some couple of 3 years ago in order to identify the number and also the shape and thickness of these radicular arteries. This is the spinal cord in a dorsal view and a ventral view. And as you see, some of these radicular arteries sometimes are connected, as in this case, C1, C2, C3, the dorsal ones. And the ventral ones, the biggest, are the first and the third in both sides. 7 gets bigger again. And then here at the lumbar level, we have the L4 and L5. L5 considered as the Adamkiewicz artery, right? And sometimes blue marks the veins and red marks the arteries. Not all the spinal segments gets vascularized, so they get a radicular artery or a radicular vein, as you see. Well, thank you very much.